Hello and welcome. In this video we will be showing how to do modeling, cuts to planes, list number and fab review for a warehouse project. This warehouse will have a welded assembly in the middle of the span, and we will be doing the assembly as an assembly inside of Revit, and we will be detailing it like this. So another exercise in here is that we have the warehouse split it into two areas. Area 1 that is having a direction in that direction, and an opposite direction in area 2. So we have to list a number in two different directions for these two areas. So let's start doing that inside of Revit. Starting with architectural modeling here, we'll model a pipe first, and this pipe would be the ranges pipe. So I'll start with 65 and moving that pipe from here. Notice that we are modeling in 3D, we're not modeling in 2D, and I'll show you all the tools that you want to use inside of the 3D. So I will choose to move about 800 from that face, and then I will follow the slope of the roof. So I'll go again, slope, and make that let's say 65 hard under the purlins. Pick a face and let's click on that. So you have the pipe in here, and then let's draw a main pipe. So create similar, and let's choose this to be 150, and let's pull it from that point up to that point. Same idea, we will just offset from faces. So we're going to the slope pipes, and I will choose 1250 mil to go from the side of the wall. Side of the wall. Yep. And then I will choose to offset from the roof. So same thing, slope again, offset from the roof by 500, big face, and then I can just offset both in that direction. So I'm going to mirror, so I'll draw the mirror in here, and that will mirror everything on the other side. So we could use the auto design and all of that, but we will have problems in the assembly that we have in the middle. So that's why I'm using this technique in modeling this network. So we don't have to repeat all of that work back again a lot of times with the number of the ranges. That's 65, and that is 65. So both of them, I will change the type to metered, and then I will trim both of them. That's to make a metered connection in the middle of the span. And then I can return them back to RZC or MBF galvanized tab. Can choose both of them as well to be galvanized tab. Alright, that easy. Now we want to distribute the sprinklers on it. So the first thing is to go to the auto design tools and sprinkler distributor. I'll choose the start of the pipe, and then the starting offset is 150, the equal distance 3000, and I will choose this sprinkler type pendant, 25 mil size, and they will populate sprinklers. This option is for the connection of the sprinklers. Because sprinklers are aligned vertically with the pipe, we need to choose snap, but because the pipe will snap under the pipe, it will snap automatically. So this option at this case will work because the sprinkler is very near to the pipe. Then I will say okay. You will get the sprinkler spreaded on the first range side, and then I will do the same from the other end, doing that thing in here, same everything, populate the sprinklers, just say okay, everything is done and automatically connected. Let's model this part in here that we wanted to do. So if you look again here, you'll find that we have 300 mil of piece welded to a 3000 mil pipe. So let's do that model. In here you can put the length of the leg to be 300, and this is 300. So both areas now are 300. And if you go to a floor plan, you can see that we can work on that one to be 700. So the best thing is to use a cut tool in a floor plan or in a 2D floor plan to choose that 2700. Click on that, and you will get a pipe that is 2700 and plus 300. Now this is 3000 and the other piece is 300. Now let's go back in the 3D. You'll find this is the piece, the welded piece that we need to the welded assembly, and I will put that assembly into a assembly. So modify that, create an assembly out of Revit. Let's make this like mid-span or whatever name you choose, 01, which is okay. Now you got that connected, you got the sprinklers done. Let's auto connect these, so you click on those pipes and then you can choose auto connect from here. So auto connector, that will place the connectors in here, and the same in the other AC from your keyboard, and you can put the connections. I can show again how this to be done. Go to view, we go to the keyboard shortcuts, and let's say amplifier tools. So in the amplifier tools, you can specify anything you want, like this is the length, adjust the pipe length, or you cut pipe, like cut, sign. You can choose the list to be list, LST, sign, and I'll choose also the delete pipe in here. So I will choose del P, sign. What else? There are a lot. Even auto branch, I think I've done that part, but let's start. Now there is a request in here, or a condition, that this is not the type of condition we do. We have to increase the branch outlet on the lower part or the lower pipe up to the other branch outlet here. So it can be one piece of pipe that is welded into the main. To do this, you select the main itself, and then you go to the properties, change the custom center to center to be something like 370. Let's say is connected in an inverter and can no longer, no, we don't want to do that. So let's do a lesser number, 350. No, cancel. Let's choose 320. Still not the best. Sorry. 300. 300 was okay. So this is the first trail. So with this done, you'll find that you have here, let's make this HH, you'll find that there is a pipe in between, and I want to delete that pipe. So to delete the pipe, we said force DLB and delete that pipe, and now I can reset the temporary height isolate. So this is the first part. I can do the same on the other part, and then we can replicate all of this or duplicate. This is from the custom PO. I can change the custom PO into 300 as we did before. Same thing. Same thing. I will select these couplings and then HH from the keyboard, DLB, and I will delete that small by scale, and now reset the temporary height. Once everything is fine, the first range is okay, I can replicate all of these ranges into a whole network. So I can select this, remove the mains, and then amplifier. You need to choose or use the bulk copy elements from our tools, because the assembly, the array will break out the assembly after ungrouping. So the best option is to use the copy elements. So if you copy elements, you choose the count to be 37 and the equal distance to be 3000, and this will replicate 37 times. So bulk copy, and then pick to which side the copy you want to do the copy. So you click on that side and it will replicate on that side. Wait for it, just copying 37 times. That's okay, just a warning. And then you'll find that you replicated everything. You'll find that the same assembly is replicated everywhere, so you keep the detail and you keep everything. So hopefully this gives an understanding why I used this approach to keep these assemblies and not doing it a lot and copying and keeping that hassle. That is the best way to do it. Now I can go back and continue my network, like if this is the main branch or the main point of source to get into the network, I can continue modeling from there in the 3D. So to use a pipe in a 3D, I can use straight away the auto branch, and the auto branch will give me an option to draw a pipe, maybe in down or something like that. So I can choose from end or at a point. I will choose from end 0, so it can be right at the end, and then I will choose down and then click on that. Okay, so you get the vertical pipe smooth and easy. And then you want to extend this a bit, you use the other tool, which is the adjust pipe length. But instead of adjust pipe length from here, I will choose my keyboard shortcuts, which is len for adjust pipe length, LEN, and click on the base point, and let's make this 9000. Change the pipe length, then you get the pipe, click on that, and then you can draw again auto branch AB, and I can use to the left and click on the end. It gives me a pipe to the left. So this is very intuitive way of modeling in 3D. I can change this to be 1200, change length, and then auto branch again. I can use something like forward, so I choose forward from that end, and so on. Also you can choose whatever you want in here as a branch outlet or running pipes on it. So you got the modeling done, and now I want to list and number. So let's move into the steps that you have to 3D modeling done. Now cut to stock lens. To cut to stock lens, we need to define the direction because area 1 has direction and area 2 has an opposite direction. So we have to define to the network what direction the network should work on. So let's go to the level 1, or I can still in 3D. I can continue working in 3D like this. So in the 3D, I will choose these pipes, these ranges, and assign set start by for it. You click on any of the endpoints that is far from the other area, so I can click in this and it will tell you that it's assigned already. Saying OK, and now let's go back to our work. So we have done the direction for the network. Now let's go and cut pipes. So to cut pipes, I will choose a shortcut, which is cut, CUT, or you can choose it from the ribbon here. The maximum length is 6500 mil and 6500 mil for ranges. You can specify whatever values you like. Click OK and then click on the beginning of the network. And just wait for the tool to do the cutting for you. The best thing in the cutting tool is that it knows where the intersections are, so it doesn't cut at the intersection, which is wrong. And also it keeps the connection after cutting, and it obeys or restricts to the maximum cut length you set forth in the dialog. Okay, so you'll find all of your network has been cut to the right length, and like this is 65, this is 65 mil, 100 mil, and all of that. So you have done the cutting very well, and you can continue to cut from the other end. So to cut from the other end, we may choose to start from here or from the other end. It's really okay to do whatever area is, but I will, in this exercise, I will choose to start from here. So I would say okay, and I will start to cut the network from here. So this is area 2. We are accessing area 2 now and cutting it to the stock lens, which runs in a different direction from area 1. Okay, so you get everything there, Everything is cut to the stock length. See the length in here, and the mains as well. This is smaller than the custom lens because it will cut on a intersection here. That's why it respected the intersection by 150 mil and set back by this distance to allow the intersection to take place. Now let's do the listing, which is populate the pipe properties, like what intersection on each pipe and what is the length and all of that. So to do this, I will start to do list pipes, and then I will choose the floor plans, level 1, click OK, and start from here. At the end of the listing tool and the end of the any tool that amplifier does, it colors the pipes, so you know what pipes are affected by the tool and what pipes are not considered in the tool, or the tool didn't work on it. So as you can see, you'll find that all of the green pipes have been listed. If you go to level 1, you see the dimensions over each intersection, and the SM is abbreviation called sloped measurement, which is indicating that this horizontal distance is not correct if you measure it from the drawing. It's a sloped measurement. This value is a sloped measurement, not a horizontal measurement. So we can start doing the other half same way in here. So let's do the listing from the other half. List pipes, say OK, and start the listing process from the other half. Save changes. Now we will get also in here what is the properties. So what is the diameter for listing, what's the start BAP, what is the end BAP, and what is the first random is 150. If you remember, it was the populate in the spread sprinklers, it was the offset, and that is the branch outlet, and 25 down, 25 down, the two BAPs. So all of the pipes are having now all these properties done. Now the next thing is to do the numbering for the network. So to do numbering, I will start from here doing numbering. So I'll go to number pipes and start with A, and starting tag is 1, and let's go from number 00 as a format, 65, that's okay, and the ranges as RR and 1 and 0, all of that's fine. The tolerance, the lens tolerance is 5, and that is the tolerance or threshold by which you say, or you dictate that both pipes are equal in length, like 1000 and 1005. If this is the case, then both pipes are same length. BAP's parameter tolerance is 5, and this is comparing the running lengths for the BAPs. If they are within 5 millimeters, then they consider the same. This is to group pipes under same number if exists. And then you say OK, and you click on the first pipe and wait for the tool to populate the numbers. So take a screenshot of what we get here, like the maximum is 826. So just take it in here, and then you can continue from the other half. As well, very visual, very basic visual review will help you understanding what pipes are numbered and what pipes are left if not numbered, but it seems here everything is numbered correctly. Now let's go with the numbering for the other half. So I will do the same, going to pipe numbers. And this time I will not start with 1, I will start with 27 because the last one was 826. So this one starts with 27 and I can just continue. Okay. All of the pipes are 65 and 150 mil, so we don't have ranges in this project. No. So from here we understand that all of this have been numbered. But these two pipes still not numbered. It even has a comment like, yeah, they are numbered, but they are not colored. This is weird. Now this is A36, A36. They are numbered, but they are not colored. Okay. So getting the numbers and getting all of that are fine. Now let's go to the level 1 again and see the dimensions, and all of that are populated. Now I can tag the pipes. So I'm going to amplifier tool and start tagging the pipes. So tag pipe parameter and choose what category. So I will click one element of the category. I want the pipes, so I want to tag the, let's say the size, and then I'll choose the pipe size tag, which is 25, and I will make this on top in the middle, and then I will place tags. So this gives you the tag inside of the pipe, in the middle of the pipe, in here. Now if you go to the pipe numbers, if you go to the tag again and click on the pipe, then you need to go to the same thing, you choose a parameter. So in this one I will choose the pipe number listing. So I will choose the pipe number listing, and then I will choose the after the pipe number listing I can choose a red, let's say 3 character, yeah, or I can use a magenta, and then I will choose at the end offset by 25, and I can put a leader in here, I can put 300 and then place. So every pipe should have its number at its end in here. So this is the end of the pipe, A4, this is A5, this is A6 and all of that, and this is A3. I can Control Z and choose another value from the end. Let's make it 500, let's say. Again, by pipe number listing. So choose pipe number listing first as a parameter. So I need to choose pipe number listing, and then the family is magenta, and I will choose a leader like 300, and from here choose, let's say 400, and place tags. So this unifies that you have a tag at the end of the pipe. If you have other information, you can choose to place it somewhere else on the pipe, so it can be neat and clean. So we listed the pipes, we put everything in there, we have a 3D. Now let's go to the schedule. If you go to the schedule here, you'll find that you have the pipes, and you have all of the pipes are here. A23, A24, A25. There is one thing that we have to be cautious about, is to search for this pipe. And what is the number of that pipe? The pipe is A26. This pipe is part of assembly. It should not show in the schedule. So to do this, you go to the schedule and make sure A26 is not shown. So behind that is the filtering. So in the filtering, we add assembly name as a parameter here. At the end, you'll find assembly name. So after adding the assembly name parameter, we put a filter like the assembly name has no value. So all of the pipes here does not belong to an assembly. That is a filter. So the pipes are not shown in here that are in the assembly. Now let's close this. I can do a fab review for the whole drawing. The best thing is to WT, say WT, so the floor plan and the 3D are shown, both of them. And now you can run the tool. After running the tool, bring it to the left like this and choose Revit to be side by side with it. Now read from schedule, use schedule, the schedule that we just opened there. So this is the first pipe. This is not shown here, but it is that pipe down at the middle, down at the corner. This is dummy lens and all of that. This is because you don't have dummy lens. So I will do the dummy lens prior to all of this. Let me go back again. I'll choose all of these pipes and go to the dummy lens. So round up pipe lenses. Done. Now let's go to schedule, see if the lenses are populated. Lenses are okay now. Perfect. Now let's run the tool again and do the same setup we have done just a moment ago. And let's move that to the left. Read, use. And this is the first pipe. If you don't want a PE, you can change it to PE and you can make this like 900. That's okay. And commit changes. This will commit changes to this pipe. And then you go to next. You get that pipe, GG, everything is fine. See that? You see here. Next, in 3D, it's a vertical pipe, and this is A4. Then you get the A5, and you get the diameter, get all of the running babs. You can check on the dimension from here. What is the first dimension? 350 rounded, and then you will get the other one, which is 350 rounded, and the other one which is 6350. Notice that we don't have SM here because that's a horizontal pipe, that's a true lens. Okay, now we change all of that and you go and check every pipe like this. If you have different pipe count, it will show in this box. So here you have 38 pipe of this lens. So this pipe, you can continue to go iterate around them this way. Yep. And so on. So you can change the data, you can do all of that. If you have if you change the model, you do coordination or whatever you do after you do the fabrication listing, you can consolidate list. And consolidate list is searching for the pipes that has defects or have stale data or data that is old from the fresh data you have now in the model. So you can consolidate list now. and search for if some pipes are wrong or are outdated. You should not have this now because you fixed all the lenses. Maybe you can get at the first pipe we change the lens for the PE, which is the plain end. But let's see. So no problem discovered. Perfect. And no pipe here. If you want to start over, you can read again and use schedule. Perfect. So this is about the review. So you reviewed your data, everything is fine, and now you are ready to export your schedule. So you can go to Amplifier Tools and export cutting sheet. Choose the cutting sheet that we have just used. The MBF export schedule 1, MBF export schedule 1 typical, and let's export it. Let's browse this PC, demos, warehouse, okay, export. So the Excel is exported. Up till now, up till here, everything is fine, and we did all the listings we wanted. Now let's go to the other part, which is the exported Excel. Yes, cool. So we got an exported Excel in here that you can use our template to copy all of the data and change it or transfer it to our template so it can look nice and cleaner than this if you'd like. So let's don't save and let's go back. There is another tool that can export PDF straight away here, PDF export cutting sheets, but still in a beta version. So we will confirm once it is done for exporting or for use. It is ready for use. We will announce about it. Now we can do store lists as well for the whole building. And this is about selecting all the pipes, and then let's map everything inside of this. Ply, carbon steel, whatever. This is B, this is G, T, S, T, elbows. I can navigate to which elbow is this. That's it. You can ignore that one. Do not give it anything. And then view sample for the other one. That's a grooved elbow. So I will assign abbreviation. This is for US only. You can use this one for metric wallet map by custom description. So I will use fittings grooved, and then I will choose description to be like this and the finish to be black. Or I can choose galvanized. And then save and continue. Sprinkler, assign abbreviation, choose sprinklers, choose the same name, and the finish is black. Save. And let's go to the other one, which is the couplings. So I can see what is that thing if I'm not sure. So I can assign abbreviation here. And this fittings grooved, vac, finish is galvanized. Save. I can save what I did into here, which is metric defaults. So I can choose to apply it again when I start working. Perfect. Now assign. And wait for it to assign, say okay, everything is fine now. I can export the PDF. After listing and mapping everything, I can do a store list out of the model like this. So you select try to select this pipe first and its span, and let's select all instances visible in view. It's 38. Go and hide them temporarily, so I can say hide element temporarily. So you can export now all the welded or loose specs out of the job without that welded assembly. So I'm going here to say I want to get a material PDF. So it's counting 2000 elements in the background. And once done, it will populate the window for us, getting all the information out of the model. So it is done. The job number is, let's say, 001. The job name is warehouse WEG, and the location is NSW. Specs and installation. Contract number is 1022, whatever. List number is 01 by LIN. Area is area 2, area 1 and 2, let's say. And this is the date of doing the listing. Now the material itself, you can choose to see what is there, but you can export straight away. You have also option to print pipe layouts if you want, and export Excel for materials as a separate work. I can show you all of that in a moment. So let's go to the C, and let's go to after C demos, and I will choose warehouse. Okay, give it a name like warehouse WE materials. Same thing, same area. WE warehouse materials. Okay. Now this is a PDF. You have the loose specs at the beginning. So you have a coupling, you have that elbow, and you have rigid couplings. For the sprinklers, you have this count of sprinklers and the finish. You have also pipes that are not welded but GG grooved but not welded at the beginning, after that. And these are the pipe sketches if you are interested in pipe sketches one by one. So the quantity, diameter, running lengths, and what are the description on each one of these. After the pipe sketches, you'll find some pipes that are not GG, and it should show in here, not welded pipes. After that, you'll find all the materials combined, the materials that are welded and not welded and all of that. So this is the total material list, and you have also but what is mentioned in the beginning of the report is only the loose specs of the materials. After that, you have as well the Excel itself. So WE warehouse Excel is still evolving this Excel, but I can show you a sample how it looks. So that is the Excel straight away here, and you can color all of these like that. will be automatic, still under progress. So that is Excel. Don't save. All good. Now we finished all of that, but we didn't detail the assembly yet. So let's detail the assembly. Let's start from here. Let's detail this assembly. So to detail the assembly, select any of these assemblies and start doing the tool that is detail pipe assembly. So detail pipe assembly works only on the assemblies like that, like a pipe and another pipes or another fittings, but at the end you have different directions. You don't have one straight line. It doesn't work on one pipe. It works on several connected pipes. So you choose detail pipe assemblies, and then you choose the title block. What the sheet name? Let's say mid span assembly details. And what is the maximum number of columns? Maybe you choose 2 different assemblies and you want to place it on one sheet. You can do that, and how you want to do it. Like if you make it 2, it will be one under another. If you make it 1, it will be all horizontal line, like first one and then beside it the second one, and so on. So I can choose whatever number I like. It's only 1, and then you will get this assembly done in here. All these done for you, the count, the size, and what is the name, what is the material, what is the start treatment of the assembly, which is G, and then what is the end assembly, which is G. Maybe it's missing in here for some reason, but you can just fix it like that way very quickly. And you have this 3D done as well, placed for you. You can place it in here. I can remove that one, this edge, very easily like this. You modify, choose invisible line, and click on these lines to disappear this way. So you get the welded piece done. We detailed it. We make 3D modeling. We made cut to length. So we did all of that, and in less than 1 hour. Thank you very much for joining us today, and enjoy using MB5.